out what's going on, right? Oh yes, I'll read it later. Do you mind getting that? Yes, I do. Do you mind getting that? The sun. It's supposed to be on top of the sun. What's the train going to do? Yes, I'm aware of this. You mean take it before? I have no work. Alright, so the next part I think is Thank you. Okay, guys. Come on. So page 86. So we're just going to have a look at averages. Okay, so guys, come on, let's start now, please. So although we talk about average a lot and people would know what average is from even elementary schools, we have to be careful with our language because there are three types of averages that we will look at. Well, actually four. Mean average, median average, and mode average. So these are the three types. This is the one which you learn about in high school, the mean average. And the one which you first learn about the mean average. Some people might know about median and mode. Okay, so I just need the definitions of each. So the mean average of your data is add up all the data and then divide by the total, divide by how much data you have, how many points. The median is the value at the 50 percentile. So this might be new for some people. So the 50th percentile, that is the value exactly in the middle if you were to put your data in order from smallest to biggest. So if you rank your data from smallest to biggest, the 50th percentile, the median, is the piece exactly in the middle, from minimum to maximum. And then the mode average is whatever value is most common in your data. So it's not enough to say calculate the average or what is the average. You now have to say which of the three types you're talking about, mean, median or mode average. Okay. So let's do the different possibilities you could be asked for to calculate. So the first one, which I usually see in section A, is they give you a list of data and they ask you for the mean, the median and the mode. So here's our first example then. So for this list, I would like the mean, median and mode. So with this question, what you should do first Yeah, rearrange them. Order them from smallest to biggest. So you start off with 0, 1, 1 and 1. There's a 2 next. And there's a 3 next. And then there's a 5, a 5 and a 6. So if you were to count these up, you can see you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you have 9 numbers, the median is at, what position is that? It's at the 5th position. Because the middle of 1 to 9 is 5. And if you have trouble seeing that, what you can do is you can get to it by cancelling either end. So you can cancel the first and the last, 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 and you can see that you get to 2, which is also the 5th number. 1, 2, 3, 4, 5. So definitely here the median is 5. And if you're wondering what do you do if you don't have an odd number, if instead you have an even number. Oh sorry, I wrote 5, right. Median is 2, yeah. If you have an even number, so there's no clear middle, you probably know what to do. You take the middle 2 numbers, you add them and divide by 2. So for example, if it was something like this, 1, 2, 2, 4, well maybe not quite that, 1, 2, 3, 4, the median here would be these added together divided by 2, so that's 2.5. Okay, so that's median. Yeah. That's okay, That's okay. So we have median here of 2.5 in this one. Okay. Right, next is the mode, so you can see that straight away. Which number in this example here is most common? 1. The mode is 1. What do you do if it was tied? For example, if you had 1, 1, 1 and 2, 2, 2.
1 and 2.
Nope. Nope. So if it's not clear, then there is no mode. Okay, so if you have like 1, 1, 1 and 2, 2, 2, then there is no mode. So the mode must be clear. It must be most frequent above everything else. Okay, most common above everything else. So this one does have a mode, but a lot of the time you don't have a mode. Okay, so the mode here, but by the way, again, it's interesting because different computer programs would deal with calculating the mode differently. For example, can I scroll down? I'll scroll to the side just for a minute. So I think in Excel, if you had like a list of numbers like this, I'll just do 4 numbers to make it easy. If you ask Excel to calculate, what way did they do it? They go A here, don't they? 1, 2, 3, 4. If you ask Excel to calculate this list of numbers, or what's the mode of this list of numbers, it will tell you that the mode is 1. And then strangely I noticed in Excel, at least the last version I looked at, if you were to reorder these numbers like this, it will tell you that the mode now is actually 2, even though it's the same list. So I don't know if this is done on purpose or if it's an error, but I think what's happening in the Excel program is it goes and it looks and it says here's 1, here's 1, okay, so far I have 2 of these, is there anything else which you can do better? 1, 2, no. You see, it looks for what's most common and then it will wait to see if there's something more common than that. So it has in its mind at the start that 1 is the most common, and it doesn't find anything more common. That's why when you reorder it and it starts at the top of the list, this time it will give you 2. Yes, actually, I think so. If you went 1, 2, 3, 4, it might report the mode as 1 then. that's worth trying. It's important that you know this too, because if you were using your program later at university or something, and you were asked to calculate the mode, and then you reorder your list, and you get a different answer, you might be wondering, what did I do wrong? Well, it's possible that you didn't do anything wrong. And this is just for Excel as well. I don't think it'll be the case for other programs. We'll have a look now. Okay, while that's no problem. While that's loading up, let's get the median. So for the median, we need to add all of these together and then divide by 9. So can you take out your calculators and do that for me? So add all these numbers and then divide by 9. What is it? Sure? Yeah?
2.6.
Yes, are you sure?
Yeah.
So the median is 2.67. Alright, let's see what happens. So we'll go with 1.1. Now this is a newer version of Excel, so maybe it's not a problem. Now really it should say no answer, and it goes for 1. Now if I change this to 2211, and that goes for 2.
2 and 2.
And then 1, 2, 3, 4. Ah, okay, this time it's smart enough. But what's the other one you said? 1, 2, 1, 2. I'm predicting 1 for that one. Yeah. So you can see that whatever the program's doing, it starts and moves down until, and it keeps a number for the mode and then waits until it finds something else that it can do better than that. But it doesn't bother to check at the end if something tied with it. So really I feel like if you have 1, 1, 2, 2, it should say here NA, just like it did for 1, 2, 3, 4. See how it says NA. Okay, and then let's see how the other program handles it. Do you talk about mean, median and mode in biology or not? Or no. Just mean? You just called it average, which is mean.
Which is median.
Yes, okay. Alright, let's see how OpenOffice deals with 1, 1, 2, 2. Tut. Looks exactly the same. Yeah. Okay, we'll close those. Oh. Weird. So, 2211. So I wonder if it's the smallest number in my list it takes. So if I go now... 1, 2, 1, 2, if it's still 1. And then if I go 2, 1, 2, 1, still 1. Ah, so OpenOffice, if it has a choice, it gives you the smallest number. What? Well, go try. I invite you to see what happens in Apple later if you try it, okay? Not now, later. It can be a research project for you. Okay. Right, so we have mean, median, and mode, so that's fine. Now what about when we do mean, median, mode if we have a frequency table? So for example, if you have some data like this. So this maybe is counting how many siblings someone has or how many phones, laptops, whatever. You're asking people how many of a thing do they have. So your choices are they could have none of it, 1 of it, 2 of it, or 3 of it, if it's phones, I suppose. So in your class, maybe one student says they don't have a phone. And then maybe most students say or not most, maybe some students maybe have one phone. Then maybe a lot of people have two phones, one for at home and one for here or whatever, so this could be 12. And then maybe there's a couple of weirdos and they have three phones, that can be 2. Yeah. So here we want the mean, median and mode from a frequency table. So first we'll do the mean. So a very common mistake, well not very common, but a common mistake in the exam is students go, okay, 0 plus 1 plus 2 plus 3, but that's divided by 4, but that's completely wrong because you definitely have more than 4 students. In fact, you had 5 students here that said they had one phone. So really it should be, you had one person say 0, so there's a 0 there, and then you had 5 people say 1, and then you had 12 people say 2. But you realise, this is a very long way to do it. And how many students do you have? Well, you'd have 1 plus 5 plus 12 plus 2 students. But you notice that, well, you have 5 of these, so that's just 5 times 1. And how many 2s do you have? 12 of them, so there's 12 2s. 12 2s is 24. So you can come up with this rather quick formula for the mean. And I haven't said it yet, but this is the symbol for the mean. The mean average is you multiply the frequencies by the value of the data divided by the total frequency. You have it already? Well, let me put it in. So it will be 0 plus 5 plus 24 plus 6 all over 0 plus 1 plus 2 plus 3. And what did that come out as? Well, that's 35 over 6, isn't it? So what's that, 5.66? 1? Oh, sorry, I screwed up my denominator, thanks.
Yeah, so 1.75.
I should have had here 1 plus 5 plus 12 plus 2. Sorry, the reason I screwed it up is because we don't actually write our tables like this. It's usually written the other way around. The frequency is on the bottom and the date is on the top. I mean, there's no rule saying that. It's just usual. Okay? So really I should have put in the X on the top, which is what I probably do in the lesson. Yeah. Okay, anyways, what's this here?
1.75.
1.75. You don't need to change your table, okay? Just make note that it's usually the frequencies on the second row, but so I don't get confused again, I'll change it. Okay, so that is the mean. So next is the mode, and that's actually very easy to do here. We can see straight away what the mode is. Yeah, because you have 12 of them. So the mode here is 2. Okay, maybe not so clear now, or maybe somebody has an idea. How could I find the median?
How multiply all the frequencies?
Yeah, so that's the first step. What's all the frequencies added together?
20.
What is it? 20. So what's half of 20? 10. So the median is at position 10 and position 11, the middle of the two. It's the 10th and the 11th divided by 2. So if we count them up, here we have the first term, and here we have the second to the 6th because there's 5 more. So this will go 1, 2, 3, 4, 5, 6 people so far. 7, 8, 9, 10, and 11 is what I need, isn't it? The 10th and the 11th person. And then there's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's like our 20 people, if I put them as little dots. So you can see the two people I care about, they both have the same value for x, it's 2. So here, what is the median? Yeah, the median is 2 plus 2 over 2, so the median is 2 also. When it comes to data, the best kind of data that you could have is data in which the mean, the median and mode are all the same, because that usually means that your data has a nice bell shape to it, which we'll look at later. But if you've done your histogram, in biology, the ragweed, wasn't it? Pollen. So if you want your histogram to be a nice bell shape, then that usually means the mean, median and mode are all the same, roughly. Okay. So we've done frequency table, but now we'll have a look at what to do if it's a grouped frequency table. Right, you can scroll down. So for example, here's the X, here's the F. So I'll just put 3 in just to give you the idea. So we'll go with 0 to 3, 4 to 7, 8 to 10. What is the upper boundary here for the first class? 3.5. What's the lower boundary? 0 or minus 0.5. It depends on the data, if negative as possible. So if here x is counting number of siblings, then 0. What is the midpoint? What's the midpoint here?
5, 6,
Yeah, it'd be about wouldn't quite be 1.5. So anyway, 1.75 I think, divided by 2, yeah. And before you start this question, you have to write in the lower, the upper and the mid. So I'll put in the lower first, 0, and then the upper here is the same as the lower on the next one, so that's a 3.5. And then here, 7.5, and then here, 10.5. So the midpoint, let me write it above it in blue. So here the midpoint would be 1.75. And here the midpoint would be, what's that? 5.5, isn't it? 5.5, yeah. And then 9. So the reason for the midpoint is that when we want to use our formula for the mean, we need to be clear with what the x is. So when I look at the first cell, the first class, do we use 0, do we use 3, or do we use something else? So the reason we use the midpoint, it's our best estimate for what the values would roughly be close to in this cell. For example, if I said there are 2 people with 0 to 3 siblings, you don't know if that means 2 people have 0, so you could have like a 0 and a 0, or maybe both of them have 3, or one of them has 1 and the other one has 2. You don't know. The best estimate you can do is to say both of them has 1.75. Now, of course, they can't have 1.75, but it makes the error in your mean small. So it's your best estimate is to use the midpoint. You say, okay, these 2 people, they have 1.75. The next 3 people, they have 5.5, and then the final 2 people, they have 9. So our formula would be 2 times 1.75 plus 3 times 5.5 plus 2 times 9 all over 2 plus 3 plus 2. So I can see the answer is probably going to be roughly 5. If you can type that in, please. .46, yeah, should be about 5. Okay, maybe we can see what the mode is. The mode is as well. So that's the mean. What do you think the mode is? Yeah, well, we have to report one number, 5.5. Now, you might say the mode here isn't really suitable because we don't know the exact numbers. It's really impossible to have most people with 5.5 siblings. But again, what's a big difference between this and previous examples is these are all estimates. So if you want to be really clear, I should really write this. Okay, and finally, the median. What about the median here? What do you think? As an estimate, roughly. What would you say? 5.5. Yeah. But in fact, later we can see that we can do from this data a better estimate than 5.5. But at the moment we'll just say 5.5. Well, actually, in this case here, I think it would be 5.5 as well. What I mean by there is a better way to calculate the estimate of the median is if some people remember doing these types of graphs from middle school, and then you go across and down, and then this is the median here. Cumulative frequency, yeah. Now, we'll have a lesson on that, but if some people remember it, that's a more accurate way to estimate the median than this. But it's only an estimate. Okay, there's one other type of average to look at. So we've done mean, median, and mode. So we have lastly, I think we want to have a look at weighted. Yeah. Interesting story here with weighted average. When I look at the syllabus to plan what to do, the syllabus does not list weighted average. It only lists mean, median, and mode. So why bother to do this if it's not on the syllabus? Well, I had a feeling since I started that they would accidentally put weighted average in the exam, because usually most maths books group the 4 together in one chapter, mean, median, mode, and weighted. So one year they included weighted average, and then what happens is, as you know, I think I told you this, they hire different people every few years to write the exam. So then someone maybe 2 years later goes, let me look at past papers. Oh, weighted average, I'll ask one of those. So now all of a sudden it's part of the exam, even though it was never part of the syllabus. But I think Lorraine would say the same thing as well. There's a couple of topics which we do, which is not on the syllabus, because we have a good feeling that by accident they might come up on the exam. So this is a good example of one of those topics, weighted average. And it's not very difficult to calculate. It looks very, very similar to one of the formulas we had earlier today. And when do you need weighted average? You need to use weighted average when not all of your data has the same importance. And a good example is with your maths results. So you know that you had your mid-semester 1, your semester 1 assignment, your end of semester 1, your semester 2 assignment, and your end of semester 2. So here is the, I don't know, the percent here, and then here is the mark that you got. So you know it would be wrong just to add all of these numbers together and divide by 5 and take that as your maths result. That's not your maths result, because you know some of these are worth more than others. Which is worth the most? The final exam. So this is worth 10%, 10%, 30%, 40%, no sorry, the last one's 40, this is 10%, 40%. These are called the weights. So let's put in some numbers as an example. So let's say you got 90 marks in the first one, 80 in the second one, 70 in the next one, 70 in the next one, and then 40 in the last one. It's realistic, actually. So if you want to calculate your average maths grade, you have to weigh them. So you don't just add and divide by 5. What you have is the average here now is the sum of the weights multiply the results or the data divided by the total weight. So here it will be 10 times 90, well I just can put that in, 900 plus 800 plus 2100 plus 700 plus 1600 divided by, and you know that the total weight is 100. That all of these weights add to 100. So can you just calculate that for me, please? Tell me what you get. What's wrong? 61. A B. Same as what? Well, it's the same. It looks the same, but there is a big difference just in the idea that with the last one here, you're thinking about this one here. The frequency is because the data is repeated. Here, you only get 90 once. Like if you ask someone here, how many times do you have 90? 1, 1, 1, 1, 1. So you might think, oh, so I divide by 5 since I have 5 numbers that only happen once. But they're not all equally important. So you have to multiply them by their weights and divide by the total weight. Yeah, sorry. Okay, so just write that one down. Okay, can I scroll down? So I just want to have a look at another final group frequency example, but one with a small problem in it, and I wonder if you have an idea about how to fix the problem. So, realistically, when you ask people how many siblings you have, normally what you have on the questionnaire or whatever way you're collecting the data is they could say 0, yeah, but somewhere like Ireland or something, there's not going to be that many, so it'll be 0, 1, 2, 3, well actually no, I want to do it as bounds, sorry, 0 to 2, 3 to 5, 6 to 8, and then 9 plus. So maybe, I don't know, you ask 100 people, So this could be 100 students. This could be 60, 30, 9 and 1, an example. Okay. What's the lower bound here? 0. Here, 2.5. Here, 5.5. Here, 8.5. There's a lower and upper bound. What's the upper bound here? Infinity, kind of, because it's everything bigger than 9. Okay, what's the midpoint here? 1.25, 4, 7, and then what's the midpoint here? Infinity, yeah. So you realize the problem with this data, yeah, you don't like the infinity here because that means now you can't calculate it. If I said what's the average, you have to use this formula. So first we'd have 60 times 1.25 plus 4 times 30 plus 7 times 9 plus 1 times some possibly infinity, yes? All over 100, because I said there's 100 people here. So any ideas about what we could do instead of using infinity? Any ideas? No, definitely not.
We can take the average midpoint, it's 9%.
Yeah, you almost have it. You have a good idea there, yeah. What we can do is we can look at the lengths of each box. So the width. How wide is this box here? It's 1.25 units wide, isn't it? Oh, sorry, no, it's not. It's 2.5 units wide. How wide is the next box? 3 units wide. And the next box? 3. What's the average of those 3 numbers, please? So that's 8.5 over 3. What's that, please? No, it couldn't possibly be 4.25. Average of the 3 numbers is what? 2.8, is it? 2.8? 2.83. So what you can say is, well, each of these boxes on average are 2.83 wide. This box starts at 8.5, and although technically it goes all the way to infinity, you can't do anything with infinity, so the best we can do is say it goes to 8.5 plus 2.83. So what's 8.5 plus 2.83? What is it? Speak up. 11.33. Thank you. That would be the upper limit. Okay, and if you can do, please, 8.5 plus 11.33 divided by 2, we can get the midpoint here. What is it? Thank you. Okay, so now we can calculate the average. What's that? Yes? Yeah. In the exam like this?
Yeah.
No, I haven't seen them do anything like this in the exam, but just in case they do, because what I'm saying is it's realistic to collect your data like this. There will be a box on questionnaires that say, 9 or more. Yeah. How do I get which value?
The
Which one? Speak up. Which number?
blue one. The blue one. Units wide.
The blue one. 2.83.
Yeah.
That's the average of 2.53 and 3.
Yeah, I mean, how do you get 2.5?
What's that? No, the average of 2.5, 3 and 3 couldn't be more than 3 or less than 2.5. It has to be somewhere between 2.5 and 3. I am 100% certain of this. Yes?
Ali.
Yes, go ahead, Ali.
Basically saying, where did you get the 2.5, the 3 and the 3 from?
Oh, this 2.5?
Yeah.
That's the upper bound. Remember upper bound?
Yeah, and what about three?
Why do you
No, hang on. Just one at a time. I don't understand what the problem is here.
Can I explain it?
Right, just one question at a time. So which number do you want me to explain?
The one in blue.
Only.
There are two colours in blue. I assume you mean this one.
Yeah, 2.8.
Right. The average of 2.5, 3 and 3, calculated, it should be 2.83.
Yeah, but where do you
That's
get
in Y. And you take
Where do these numbers come from?
Yes,
These are the widths of each box. So the first box goes from 0 to 2.5. It is 2.5 wide. The next box goes from 2.5 to 5.5. It is 3 units wide. The third box goes from 5.5 to 8.5. It is 3 units wide. On average, our boxes are 2.83 units wide. So we can say the last box, we estimate it also to be 2.83 units wide. Although it technically goes to infinity. We realize most people do not have infinite number of brothers and sisters. So we estimate. Most people. Right, other questions? Right, so what is the average here? Please tell me. It should be 2.7, yeah, okay. By the way, you can see that, what's the mode as well? What's the mode? 1.25, yeah. And the median? 1.25 as well. Yeah. Suppose there was another box. Maybe this isn't siblings, maybe this is something else. Suppose there was another box where the person's answer was don't know. So you have 0 to 2, 3 to 5, 6 to 8, 9 or greater, and then don't knows. Whatever the reason, don't know. What do you think you should do with that box? Yes, yeah. So just remove that one from the data for your calculation. Other questions? You had a question, yes?
How did you get the median? Median, 1.25.
The median is the 50th person from smallest to biggest. So you can see that the first 60 people are all from 0 to 2. So the 50th person is in that box, 1.25. You always think of the medium as you line your people up from smallest to biggest and you take the person in the middle. That's the median. Yes. Anything else with this now? No. Now this would be, everything I've done would be something I've seen on the exam before, with maybe the exception of the 9+ box. Okay, they've not done anything like that in the exam before. I don't think they would though. I think that maybe is too fine of a point, or maybe too technical, okay? But even if they don't ask it on the exam, in the future when you're collecting data for whatever you're doing, that is one way you could deal with the 9+ box. And if you think back to your pollen data in biology, was any of your boxes like this, 9 or greater, they were all between two numbers clearly?
We made up.
Yeah, but I mean, all of the boxes were between two numbers. There wasn't one box at the end that said greater than whatever. No, they're all definitely between two numbers then. Okay, that's good. Alright, so you can try now the questions on 86, please.